For this week's problem of the week, I'll be doing number 2, which has 2 parts to it. The first says, find the rank of A and the basis for the null space of A, which gives us a matrix. The second part says, use the rank nullity theorem to verify your results from part A. So before we can start looking for the rank and the basis for the null space, we have to put this matrix in reduced row echelon form. So what we do is subtract the first row multiplied by 3 from the second row and store it in row 2. This is our result. Add the third row in the first row and store the result into the third row. Here's our result. And then subtract the second row from the first row and store it in the first row over here. And then add the third row to the second row, and we're going to get a row full of zeros. So now we have to find the rank, and how we can find it is just by looking at how many non-zero rows we have. And here we see this row is full of zeros, these aren't, so it's rank 2. Now, here we're going to be finding the nullity, and what we do is we write these in this form, put it back into x form, and then we solve for the x's. So right here we can see x1, x2, x3, x4, and then we write these x1, there's no x2 because it's 0, 9 is x3, 9x3, and then 10, 10x4. And then before we move on to isolating x1, we can see that these two are open variables. We can set them to s and t. They're free variables. We set them to s and t, and then we plug in for x3, s, and then for x4, t, and then solve for x, and we're going to get x1 is equal to negative 9s minus 10t. We did the same thing for x2, right? And now we put these solutions to x1, x2, x3, x4, t into here. So we have negative 9s minus 10t, 7s plus 7t, and s and t. Now we split these into 2 because we want to separate the s's and the t's to get the nullity. Now we're going to get negative 9s, 7s, s, and 0. This part 0 because there's a t there. Then negative 10t, negative 7t, 0, because this part has an s. So there's 0, and then t from here. So here we can see that the dimension of this nullity is 2, and this is the nullity itself. Now, the reason for finding the rank and the nullity helps us with the rank nullity theorem here is because the theorem states, given a matrix A, the rank of it plus the nullity is equal to n, and n is the number of columns. So, right, we know we have 4 columns, and the rank of A we found that is 2, and the nullity, the dimensions of nullity were 2, and when we add these two together, it's 4. So it was proved.